So today, as you can probably see, we've been robot testing. So we've been given 3 different tasks to do. We've had to do getting out the start loop, object avoidance, and we've also had to do fault tolerances.
It's amazing to see what the students can achieve. From day one, the students start programming and assembling the robots. So they need to do that from scratch.
So we had to start off by physically building the robot, putting it all together with the pieces we were given. And then we analysed the requirements of the system and started putting together some code that would run on the robot.
So I've been trying to teach my robot to find the starting point of a track. So how that would work, it would start in the middle of a circle, and then it would find the line of the circle and then turn onto it, and then it would go around the circle and find the starting point of the track, so it would turn off, and then it would continue to go. So there's quite a lot of programming involved in that, and that was good.
We start off with programming in the first year. So students get an idea of how to program electronic systems, microcomputer systems, how to use algorithms to tell devices what to do, and then build up on that in the second year, where they do this module. In addition to the theory that they're learning, there's also a bit of a competitive element, of course, that's quite exciting. And for us, it's great to see the development of those skills.
I'm actually a part-time student at Solent University. I come down every Tuesday to do my lessons and my courses. So far, I absolutely love the work we're doing. I'd heard Solent University was one of the best universities that our company uses, and therefore I looked into it, and when I saw the different types of subjects that they covered and different types of tasks that you get to do, making a robot follow a line, it was perfect for me.
The most fun bit for me was probably learning how to program a robot to do things, because it's a thing you sort of see and you never really get the chance to do. And it's almost like sci-fi in it, and it's really fun. I love it.
We try to make learning really industry relevant. For example, with the robots the students learn to program here, they are used in manufacturing environments. For example, the same algorithms apply where you try to transport materials from point A to point B in a manufacturing environment. And to do that, they need to follow a prescribed path and try not to hit anyone on the way, obviously.
Within individual teams, we were all given individual tasks. Mine was the avoidance task, and I must say it was a challenge with the team, but it was absolutely brilliant because all the different functions that we had, we managed to get it going properly, and our robot won overall.
What you find in real life is that the lines they're following can have certain tolerances, or there's errors on the lines, and therefore they need to be able to deal with those.
The biggest challenge for me was probably getting it to line up properly, because when it got to the line it would turn but not at the right point. So that was a lot of trial and error. It was changing the motor speeds ever so slightly, seeing which way it went, and tweaking it and tweaking it and tweaking it until it got perfectly on the line. That was probably the hardest part. It took a long time to get right. Just a lot of trial and error.
I've absolutely loved doing this today. It's been a definite insight into working with different people that I'm not used to working with, and it's been a great learning curve because for me, I'm not used to using Arduino code or Arduino IDE. I'm used to using different platforms at work, so being able to expand my knowledge has been brilliant.